let's take a look at another class of iterables in Python called dictionaries. And again, we'll look at their capabilities and limitations. So is a dictionary changeable? Yes. You can add and remove items to a dictionary just as you could with a list type iterable. Are they indexed? Yes, just like a list, but indexed by keys rather than numerically and sequentially as with a list type iterable. Are they ordered? Yes. They're ordered sequentially, not returned in a random order like a set would be. Duplicates, no, they cannot have any two items with the same value. They require a unique key value, okay? And no two key values can be the same as any other key value. To store multiple items in a single container, you can reference them by a key, so a key value pair or a set. They're created with curly braces, okay, sort of like a set, and key value pairs separated with semicolons, or followed by commas, or excuse me, colons followed by commas. Did I say? Yeah, let me get rid of that there. Okay, they can be of different data types, and like other iterables, they have a len method, update, and pop. Okay. In this example, we're going to look at just holding different data types. I'm going to hit F5. And notice a string, an integer, a boolean, and then a whole list of values here. See, all different data types, but a dictionary with its set of key value pairs is able to accommodate and hold all those different data types. I'm using the get method. So in this case, without using the square bracket syntax, if I use the get method, I can retrieve the value stored at a particular key and we'll get the same thing here. I'm just showing you, I could use the get method to retrieve the value stored in this key, or I could use the square bracket syntax to get the value. Either way, I get to the object, Twilight Sparkle, okay? Looking at our next dictionary example, we're going to use the keyword in. And we can use the keyword in to search and see if a value exists, okay? Just on a particular keyword. So if I wanted to look for the key flight capable, is flight capable that key value present inside the dictionary DCT Twilight? If it is, we'll plug it into a decision structure. If not, we'll say this key exists in the dictionary. If not, we'll say this key does not exist in the dictionary. Let's run our code. I'll hit F5. And again, this key exists in this dictionary. Okay, why? Because yes, flight capable is this key here, and then along with its value. In this next example, let's look at changing the value stored at a particular key location inside of a dictionary. So again, we define our dictionary here. And before, we get the value stored in DC Twilight, all right? And then we're going to use our square bracket syntax here. Specify the key name of the value that we want to change. So here's the column, here's the variable name, the field, right? And here's the value we're going to change it to. When we created this dictionary, the value of name was Twilight Sparkle, but we're going to change the value of name to Rainbow Dash, and then we'll simply display the whole dictionary after versus what it was before the change was made. So let's clear our console and run. So again, it was Twilight Sparkle, now it's Rainbow Dash. Just an example of using square brackets to change the value of a particular key that we specify. Let's look at another way of altering a key value pair inside of a dictionary, and that's using the update method, okay? So here, we're just going to call the update method. The key is name, and we're changing Twilight Sparkle, the previous value, to the new value, which is the string Applejack. And again, we'll display before and after. Let's clear our console, F5 to run it. Okay, so it was Twilight Sparkle, now it's Applejack. And that is using the update method to change a specified key's value. And here we're going to add new key pairs to a dictionary. So before we have these key pairs, right? But this time we're going to add another key color, another attribute, and then its value will be purple, okay? So we can do that. If I run this, look at the key value pairs before. Oh, it would help if I invoke the function. Let me do this. Let me add this down here. Okay, hit F5 to run it, and look at before and after in this example. Okay, so we have name, species, age, magic user, flight capable, and powers. We have all of those keys, but notice we've added another key here, color and purple. And we did that with this syntax here using our square brackets, all right? We added a key color, a new key, and gave it a corresponding value of purple. In this example, we're going to use the update method again. But not only can we use the update method to modify the value stored at a particular key that already exists in a dictionary, we can use update to add a new key value pair if that's what we want to do with it. And here we're calling update twice to illustrate just that point. The first time we call update, it's on a key that already exists, name. So we'll just be changing the string value Twilight Sparkle to the string value Rarity. But the next time we call update, this is on a key that was not defined in our dictionary. So that key will be created and the corresponding value assigned to it. To illustrate this, let's hit F5. Okay, so before and after the update method, we didn't add a new key the first time we used update. We just changed the value of an already existing key that was defined in that dictionary. But the second time we called update, we actually added, look, here before And then after, there's one more key. In this case, we added color, and the value we assigned to it was white. So it depends on the syntax, and it depends on whether or not that key actually already exists in the dictionary as to what update does, whether it adds a new key value pair or whether it just changes the value in a key that already exists. Here we're going to use pop to remove a specified key value pair from our dictionary. So we've defined powers here in this instance, right? And it takes a whole list inside of our dictionary of powers. Here we use the pop method to specify that it removes, see how it highlights powers? This is our key here and its value. So when I call pop, it's just going to chop off this specified key here, powers. And we'll do display before and after. I'm going to hit F5 and run. And again, illustrating the pop method, look, here we had a key powers and it contained a whole list of strings. But because we called the pop method here, and because we specified powers, it chopped off that last key value pair, hence the difference in before and after. With pop, let's also take a look at pop item. Here we're calling pop item. And if we just call that method, it'll remove the last key value pair. It'll chop off the last key value pair in our dictionary. And that, the way this dictionary is defined would be the color key and its value purple. So we're just going to chop that off by calling pop item. Okay, let me hit F5. Okay, so here's our key value pair, color purple. And notice after we call pop item, she gone. In this next example, let's take a look at using the clear method. And that'll simply clear all the key value pairs inside of a dictionary, but it won't destroy it. So if we try to access it after calling clear, it won't create an error. It won't be accessing a null object, as we did when we used delete with, say, our sets. But it will be clear. It'll be an empty dictionary. So again, let's do that. Clear the console and run this code. And look at before and after. So again, before, the dictionary is as we define it, but we call the clear method, it clears out all the key value pairs, and after, when we call it and display it with print, it's just an empty dictionary. There are no key value pairs. That's an example of clear. What if I just wanted to eliminate one, key value pair? In that case, I could call delete. I could specify my dictionary name, and then I could specify the key name. So if I want to get rid of this key here with this dictionary or this list of strings here inside my dictionary, then I'm going to call delete on it, and we'll display before and after. Let me hit F5. And notice that key, right, the powers key, and its list of string values is gone. Now let's look at using delete in a different way. I can call delete on a particular key in a dictionary and it won't wipe out the entire key. But I can also call delete on an entire dictionary object itself, which would be all the key value pairs. Now, this is different. What happens if we try to access a null object? Boom, right? We can't do that. So if I try to, once I call delete on an entire dictionary and I wipe it out, I clear memory of it, if I try to then print it or access it or do something with it, that null object is going to generate, it'll throw an exception. It'll generate an error. And to illustrate that, let's run this code here. I think I'm running 17. I may have to go uncomment the last function, but let me hit F5 here. Boom, right? So unbound local error, an exception has occurred, right? Variable DC Twilight reference before assignment. Well, I can't print DC Twilight. I can't call any function using this object. If I've called delete on the entire dictionary, it no longer exists in memory. So trying to access a null object would throw an exception. It would generate an error as expected. In this next example, let's look at using a dictionary with repetition structures, okay? So as any iterable could be used with a for loop or a repetition structure, we'll say the first time for x in DC Twilight in our dictionary, we'll display the key, and then in this case, the next time for y in DC Twilight, we'll display the value, okay? So display all the values, display all the keys, and then let's display both keys and values, in which case, so x, y, our third repetition structure or for loop, will display the key, which will be z, and then in this case, we'll convert to a string. And notice how we get the value. It's that array subscript syntax that you would use with a list or an array type iterable. So it's the square brackets, right? And then the index would be z in our third example, this third repetition structure. And we're just formatting it into columns here in the print statement. So 23 characters, 0 of it. Let's run this function and see what happens. F5. So 3 for loops. The first time we get the key name. The second time we get the value stored at that key. And the third time we get both the key and the value stored in it. Again, let's review the syntax. In A here, display all the keys in the dictionary. We're just saying for X in DC Twilight, okay? And then that retrieved all the keys the first time we ran it through the for loop. The next time, Y in DC Twilight, we're going to get all the values stored there. So first it returns the keys, then it returns the values. And if we want to get it both in our third repetition structure, our third for loop, the key is just going to be z, whatever a z indexes and goes through our dictionary, iterates through, it'll give us our key name. And then the corresponding value stored at that key, well, here we need to use list or array type syntax with those square brackets to get at the value stored in that particular key. And that's what we're doing here, right here, and in our last loop there. Okay, let's take a look at another example. And here we're going to use keys, values, and items methods to do the same thing essentially, but just to look at how would we code something using these methods with our dictionary? Well, we just take our dictionary, right? Same repetition structure, same for loop, but we'll call the keys method. Next, we'll call the values method. Next, we'll call the items method. So we're doing the same thing we did before, but this time we're using these special built-in methods, which can be a bit more convenient, not having to reinvent the wheel and calling methods that already exist in Python. But look, it essentially does the same thing using those methods. I'm going to hit F5, run this code. And again, take a look. Looping through, we get the key, name, species, age, magic user, flight capable, powers, color. The next time we get the value, Twilight Sparkle, Alicorn, 444, true, true, a list of strings here for powers and the color purple. And then the last, when we use the items method, we get the key value pair stored there. But our syntax is simplified in this instance because we're using built-in methods that work with our dictionary, our Python dictionary iterable object. You cannot copy a dictionary iterable with the assignment operator as you could with other objects in Python. There is, however, a method you can use, the copy method, to copy one dictionary to another. Here, we create a dictionary, DC Twilight, and after we define it, we'll create DC Twilight Evil Clone, and we're going to use the copy method on the dictionary that we previously created. And we'll just display both to illustrate that, in fact, that entire dictionary was copied. I'll hit F5. We'll run our code. And again, the original dictionary and DC Twilight Evil Clone are exactly the same. And that's because we used the copy method here, okay? So although you cannot use the assignment operator, the copy method is one way you can copy a dictionary to another. Another way that you could do that is by using the constructor of the dictionary itself. So here I define a dictionary, DC Twilight, And now for evil clone, I call the built-in constructor the built-in constructor of the dictionary object itself. And then I pass in DC Twilight as a parameter, as an argument to the constructor. When I do that, it has the same effect. Let me clear the screen and look, if we run the code, see? Our DC Twilight evil clone is exactly the same. It's an exact duplicate of our DC Twilight. So it was copied, but instead of the copy method, this time we used the constructor of the dictionary object itself to do our dirty work, so to speak. So let's look at nested dictionaries. So in addition to, we've already used a list type iterable in a key value pair inside of a dictionary that we've defined. In this instance, let's look at using another dictionary inside of it. So we create a dictionary here, DCT MLP characters, okay? And in that we have key value pairs, name, stars a string, species a string, age an integer, magic user and flight capable, some bulls, they're Boolean. Powers, this is our list or array type object, stores that color purple. All right, that's pony 1. Pony 2, all right, same key value pairs. Pony 3, same key value pairs. So in this case, our outer dictionary stores 3 ponies, and then each pony in our outer dictionary is itself a dictionary that has these key value pairs stored inside of it. And look at the syntax. Curly brace for the outer dictionary, and then a key value, or this would be the key name, pony 1, pony 2, pony 3, the outer key name. And then for each of those outer keys, its value would be an entire other dictionary separated by a comma with its own set of key value pairs. So we're just doing a little bit of nesting here. That's a common theme, right, in just about any programming language, and that's where you get a lot of bang for your buck in terms of coding when you start nesting one data type inside another, one repetition structure inside another, one decision structure inside another. Nesting is always a good thing, at least programmatically speaking. So we'll display that. Let's go hit F5 and run this code. All right, and notice what we're doing. We're displaying the outer key, pony 1, okay? Pony 2, let me bring my mouse cursor down here, it jumped up there, and then pony 3. And then each of those outer keys, has itself an inner dictionary, key value pairs of name and species and age, magic user, so forth, okay? So you see how that works. In this example, in the previous example, when we built that dictionary, it was a multi-dimensional dictionary, sort of like a multi-dimensional array or a multi-dimensional list, right? Which we've done in some of our game projects in this series of videos. But what if we wanted to define our dictionaries separately and then nest them one inside the other? We could do that too. So DCT pony 1, 2, and 3 here, and each of these is a dictionary with a set of key value pairs. And then look, DCT MLP chars, in this case, we just take these inner dictionaries that we previously defined and we make them the value for the outer key of our external dictionary. So these 3 here, they're defined separately, but they will become internal dictionaries that are actually the value in the key value pair of our external dictionary. So this has the same net effect as the previous function if we run it. Look, I'll hit F5, but just showing you syntactically a different way of doing the same thing. Again, pony 1, pony 2, pony 3, and the same set of key value pairs, okay? Last, let's look at our last example for dictionaries here. Okay, so again, look at how we're defining the structure. It's a nested structure. In one step, we're defining a two-dimensional dictionary. And we have our outer dictionary here. These are the key values, pony 1, pony 2, pony 3. It's going to have, 3 key value pairs. So here's the key. Well, the value for that key is itself an entire inner dictionary nested inside that outer dictionary with its own set of key value pairs separated by a comma. Okay? And if we plugged it into a for loop, how do we access it? Syntactically, how do we access a nested dictionary structure? Well, for X in DCT MLP characters, right, that's our nested dictionary, we're going to display X, and then we're going to display an array syntax DCT MLP characters with the square brackets. So an array syntax, the subscript value, that will be the inner dictionary. And then if we display X, the way this for loop is coded, that's the outer dictionary. All right, so you see how that looks syntactically. Let's run this. I'm going to hit F5. Okay, and look, here's pony 1, outer dictionary, pony 2, outer dictionary, pony 3, outer dictionary. That is this line here, print X, right? That's X. But to get at the inner dictionary nested inside the outer dictionary, we have to use a subscript value in square brackets, just like we would with list if we were using the range method, which we've gone over. And that's what we're doing here. That's the inner dictionary. So the outer dictionary, the key, and then its value is a nested inner dictionary, which is an entire set of key value pairs. And the same for pony 2, and the same for pony 3. You see how that works? Okay. Let's just review and summarize some of the methods that you can use with a dictionary class of iterable in Python. There is the clear method to remove all elements from the dictionary, copy to copy one dictionary to another, from keys returns the dictionary with the specified keys and value, get returns the value of the specified key items, returns a list containing a tuple for each key value pair, keys returns the dictionary's keys, right? Just like values returns the dictionary's values down here. Pop removes the element with the specified key. Pop item removes the last unsorted key value pair at the very end of the dictionary. Set default returns the value of the specified key. And then update updates the dictionary with the specified key value pairs. If that key value pair doesn't exist, then update will actually create a new key value pair inside the dictionary. So this is just a summary of methods that you can use with the Python class iterable of dictionary.